The topic that we are going to cover in this session is bonding in carbon and its versatility. So friends, before we move ahead with our discussion, we should know that the atomic number of carbon is 6, which means that a neutral atom of carbon contains 6 electrons. How will the distribution of electrons in different orbitals of carbon occur? But friends, why are we studying about the electronic configuration? We are studying its electronic configuration so that we can understand the type of bonding in carbon. Carbon has 4 electrons in its outermost shell. So it should either lose 4 electrons or gain 4 electrons to achieve noble gas configuration. But really, is it possible? As carbon is a small atom, so outermost electrons are held strongly by the nucleus of the atom. So, it is not possible to remove 4 electrons from carbon. Also, it is not possible to gain these many electrons due to energy considerations. Let's assume if it were to gain or lose electrons. 1. It could gain 4 electrons forming C4- anion. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Second, it could lose 4 electrons forming C4+ cation. But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Carbon atom has 4 electrons in its outermost shell, so it requires 4 more electrons to achieve the noble gas configuration, which it gets by sharing electrons. Since one carbon atom requires 4 electrons to achieve the nearest noble gas configuration, therefore, it has a valency of 4, that is, carbon is tetravalent. Not just carbon, but many other elements form molecules by sharing electrons in this manner. The shared electrons belong to the outermost shells of both the atoms and lead to both atoms attaining the noble gas configuration. Before going on to compounds of carbon, let us look at some simple molecules formed by the sharing of valence electrons. The simplest molecule formed in this manner is that of hydrogen. As we have previously studied, the atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and it requires 1 more electron to fill the K shell. So, 2 hydrogen atoms share their electrons to form a molecule of hydrogen, H2. This allows each hydrogen atom to attain the electronic configuration of the nearest noble gas, helium, which has 2 electrons in its K shell. Such bonds, which are formed by the sharing of an electron pair between 2 atoms, are known as covalent bonds. Covalently bonded molecules are seen to have strong bonds within the molecule, but intermolecular forces are weak. This gives rise to the low melting and boiling points of these compounds. Since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductors of electricity. Let us now discuss about the versatile nature of carbon. We have seen the formation of covalent bonds by the sharing of electrons in various elements and compounds. We also know the structure of a simple carbon compound, methane. We also know about how many things we use contain carbon. In fact, we ourselves are made up of carbon compounds. The nature of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon are: 1. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or even carbon atoms arranged in rings. In addition, carbon atoms may be linked by single, double, or triple bonds. Compounds of carbon which are linked by only single bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. This gives us the large number of compounds with many carbon atoms linked to each other. 2. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine and many other elements, giving rise to compounds with specific properties which depend on the elements other than carbon present in the molecule. The two characteristic features seen in carbon, that is, tetravalency and catenation, put together give rise to a large number of compounds. Many have the same non-carbon atom or group of atoms attached to different carbon chains. These compounds were initially extracted from natural substances, and it was thought that these carbon compounds or organic compounds could only be formed within a living system.